Hi, I'm Dr. Crystal Collier, and today we're talking about risky behavior and your brain. On our journey, we'll cover everything you need to know about how high-risk behavior affects and changes your brain. Let's get started. Unfortunately, I engaged in risky behavior when I was young and wound up in rehab by the time I was 18. I'm grateful to have survived, but I had a lot of shame about why I made such bad choices. So I started studying everything I could find to answer that question and learned a lot about how risky behavior affects the brain. When I heard my favorite brain researcher, Dr. Lawrence Steinberg, say, "A teenager has a well-developed accelerator, but only a partly formed brake," I started to get it. But what do you think this means for young people today? What does it mean for you? Remember, the brain develops in two phases. The limbic system, where the accelerator is fully developed by about age 12, but the frontal lobes, where the brakes are, is not fully grown until about 25. During the two brain development phases, we grow brain cell networks, like the ones that you can see in these pictures of baby neurons growing up to age 2. These networks thicken with connections that increase our brain's thinking speed and give us the ability to grow skills. But all of this brain development is based on the brain's rule: use it or lose it. So the successful navigation of your brain development journey should result in the creation of your executive functioning skills. Remember, the frontal lobe's nickname is CEO because it's the boss, in charge of all of your thinking and doing skills. Your basic executive functioning skills are the ones you need to get up in the morning, out the door on time, and remembering your homework. Your higher level executive functioning skills are the ones that you need to get up and out of your parents' house and become fully self-supporting adults with good relationship skills. You guys get how totally important these skills are. So how do substances like drugs, alcohol, and other high-risk behavior affect them while they're growing? It's all about the dopamine, a chemical your brain makes to signal when you do good things for survival, like eating. For example, how do you feel if you haven't eaten for about 7 or 8 hours? Pretty hangry. Well, your brain is decreasing the amount of dopamine to make you feel really uncomfortable, so you'll go eat. As soon as you do, your brain increases dopamine by 100%. Being with friends in intimate relationships can increase dopamine up to 150%. These behaviors are great for our survival and our species' survival. But some risky behavior spike dopamine too high. Cocaine increases dopamine up to 350%. Methamphetamines and heroin spike dopamine up to 11 and 1300%. Now, this may feel good at first, but then you run out of dopamine and feel really down. Scary. But how do dopamine surges damage the brain? First, let's look deep inside the limbic system at the brain cells that use dopamine. You'll see dopamine hitting the receptors and sending the signal down the cell to send out more dopamine. But when dopamine surges too high, the brain cells use up all the dopamine. Then you feel really low until your brain replenishes its dopamine supplies. No wonder people feel really yucky after using substances. Second, let's look at a dendrite and all its little dopamine receptor sites. The more dopamine your brain is exposed to, the more your brain learns and grows new dendrites with new dopamine receptor sites. But when all the dopamine goes away, all these new receptor sites in your brain are craving and screaming for more dopamine. You can't unmake those structures once you create them. And that's how too much dopamine from risky behaviors damages and changes the brain. But let's take a look at what it does to our frontal lobe. These scans are looking at the brain from the top, and the color indicates activity. The person on the top is completely sober. All the lights are on, lots of executive functioning skills going on there. The person on the bottom has drugs in his system. Notice that the frontal lobe has gone dark. it's shutting off while the limbic system, the accelerator, is lit up. This may be the perfect storm for a lot of bad decisions. But what if you're growing your frontal lobe and it's off? Does it get to grow? Nope. If someone starts using HEAR at the age of 12 and doesn't stop until about 20, their frontal lobe won't look like this one. This is known as arrested development, when the frontal lobe doesn't get to grow because it's off. So instead of executive functioning skills peaking where they should, they peak at younger ages. And if this person doesn't stop until after the age of 25, they may be an adult with the executive functioning skills of a younger teenager. And it takes a long time to heal from the effects of risky behavior. Here's a cocaine abuser's brain 10 days sober. They're in major detox, and here's what his brain looks like 100 days sober. The frontal lobe is just starting to turn back on. Remember that there are a lot of substances that can spike dopamine too high in our brain, but there are a lot of behaviors that can do that too. That means they have the potential to become risky or addictive. So now that you know how risky behavior affects your brain, how will you protect your frontal lobe, especially while it's growing its brakes?